Hey, what's up guys, welcome back to this video. In this video we're going to solve this coding interview question to sum. Given an array of integers nums and an integer target, return indices of two numbers such that they add up to target. So in this problem we're given an array of integers nums and a target. We have to return the indices of two numbers such that they add up to target. You may assume that each input would have exactly one solution and you may not use the same element twice. So each input have exactly one solution and we cannot use same element twice, and we can return the answer in any order. Order doesn't matter. For example, this is the first example. In this example, we're given this nums array and a target 9. We have to find out two elements in this array such that it add up to this target 9. We have in this array 2 and 7, these two elements that add up to this target 9. 2 plus 7 equals to the target element 9. So we have to return the index of this element 2 and 7, that is 0 and 1. We can return this index in any order. Order doesn't matter. We might have 1, 0. This is our second example. In this example, we're given this nums array. We have 3 elements and we have target 6. And we see that the two elements 2 and 4 add up to 6. So we have to return the index of this element 2 and the index of this element 4. That is 1 and 2. For this input, we have these two integer 3 and 3 and target 6. Here we see this two element add up to this target, so we have to return the index of this two element 0 and 1. This is the problem. Now how to solve this problem? We can solve this problem using two nested for loop pretty easily. If we run two nested for loop, one loop will point to this first element and the nested loop will iterate from this element all the way to the end for the first iteration of the outer loop. And we have here 2. Now we have to find out an element here that is 9 minus 2, 7. We see there is no 7, so we will move our outer loop to the next element here and we're gonna find out the element that is 9 minus 1, 8. We see we have here 8, so we have to return the index of this element and of this element, that is 1 and 4. But this algorithm will take of n squared time complexity. This is not the super efficient algorithm to solve this problem. The space complexity of this algorithm is constant, but this is a quadratic time solutions. This is not super efficient. We can solve this problem in linear time complexity using the concept of HashMap data structure. Let's see how to solve this problem using HashMap data structure in linear time complexity. First, let's create HashMap data structure. We know HashMap is a key value pair. So let's create HashMap data structure. Let's assume this is our HashMap data structure. Now we're going to iterate this array from left to right and we will store the value and the index. If we have duplicates, then we will store the index of last element. Here we have 2. So let's add here key 2 and the index 0. Then we have here 1. So key 1, the index 1. Then we have 3, the element 3 and index 2. Then we have 5. The index of 5 is 3. So here 5 and here 3. Then the last element is 8. So let's add here 8 and the index of 8 is 4. If we have duplicates element, let's say we have here another element 1. Then what we have to do, we have to update this index 1 with the index of this one. So we have constructed this HashMap data structure. Up until this point, we have scanned this array from left to right once. Now we're going to scan this array from left to right again. Now we're going to find the difference of target and this current element. The difference between target and this current element 2 is 7. 9 minus 2 is 7. Now we're gonna search in this hash map. We can do that in constant time. We see that 7 does not exist, so we'll move to the next element. Now we see 9 minus 1 is 8. 8 exists, so we find out our answer. So we have to return the index of 1 and the index of this element here we have on hash map. So we find out our answer, and we see that this element and this element add up to this target 9. This is the solution to this problem. If we have input like this, then this algorithm will fail. Let's see why it will fail. Let's find out the index. Let's construct the hash map. So the index of 2 is 0. The index of 3 is 1. The index of 4 is 2. Okay, so we constructed this hash map for this input. We have this array and we have this target 4. Now what I'm gonna do, I'm gonna find out the difference between the target and the current element. So 4 minus 2 is 2, and we see 2 exists, right? Since 2 exists, what I will do, we will find out the index of 2, that is 0, and here the index of 2 is 0. So it's produced a wrong answer. In that case, what I will do, I will check the index. If we find out the difference and the difference exists in our hash map, that means 4 minus 2, 2. 2 exists in the hash map. If the difference exists, then we will check the index. If the index are the same, then we will skip. We will not find out the pair. We'll find out invalid pair in this case, right? We find out invalid pair. So we will not find out pair, we will skip, we will move to the next element. We have talked about the A sketch. To solve this problem, we're scanning this array twice, but we can solve it without scanning twice. We can solve it in one pass. Let's see how to solve this problem in single pass. First, let's construct our hash map data structure. Let's assume this is our hash map data structure. Okay, this is our hash map data structure. We will have here key value here. As key, we will have the element, and as value, we will have the index. Now, let's traverse this array from left to right. First, we have 2. First thing, what I'm going to do, I'm going to find out the difference between target and this current element. That is 7. 9 minus 2 is 7. 7 does not exist. Since 7 does not exist, we're going to insert this 2 as key and the index 0 as value. Let's move to the next element. This is our next element. Now let's find out the difference. The difference is 9 minus 1 is 8. 8 does not exist in our hash map. So let's insert this element 1 as key and the index as value. Let's move to the next element. That is 3. Now let's find out the difference. 9 minus 3 is 6. 6 does not exist in the hash map. So let's insert this element 3 and the index 2. Let's move to the next element. This is our next element. Let's find out the difference. 9 minus 5 is 4, but 4 does not exist in this hash map. So let's insert here 5 and the index 3. Now let's move to the next element. The next element is 8. Let's find out the difference. Difference between 9 and 8 is 1. And we see 1 exists in the hash map. So we find out a valid pair that add up to this target 9. So what I'm going to do, I'm going to return the index of this 1, that is 1, and the index of 8 is 4. So I'm going to return this 2 value as an array. This is how we can solve this problem in single pass. This algorithm will take big of in time complexity. We're scanning this array just once, and it will take big of in space complexity. In naive approach, we solved this problem in n squared time complexity. Now we solve this problem in linear time complexity. The space complexity was for the naive approach is constant, but here we see the space complexity is O of n. We can trade off space complexity for better time complexity. Now let's see the implementation of this algorithm. Now let's implement our algorithm. First, let's create an array to store the answer. New int of size 2. Now let's create hashmap data structure, hashmap integer. Let's call it map equals to new hashmap. Now let's run a loop from index 0 all the way to the end. So for int I equals to 0, I less than nums dot length I plus plus. Now let's find out the difference between target and our current element. So int difference equals to target minus nums I. Now we're going to check if the difference exists in our hash map. So if map dot contains key, this operation will take constant time. So here difference, if the difference exists in the hash map, then what I'm going to do, I'm going to insert at index 0 the index of I. So the index of I, and at index 0 here we're going to insert whatever index we have in our hash map for the different. So map dot get different. If we find out this, so we will break it. We don't need to execute this for loop anymore if we find out this pair. Otherwise we're going to insert into our hash map the current element and the current index. At the end we will return the answer array. This algorithm will take O of n time complexity and it will take O of n space complexity. Now let's run this code. Accepted. Now let's submit it. We have successfully solved this problem. This is the algorithm to solve this problem. Hope you have understood how to solve this problem efficiently. Thanks for watching this video. I will see you in the next video.